Dear friends, welcome to this initiative series by Jhalak Education entitled Chemistry Concepts for All. The first lecture is a very basic lecture that covers definitions of elements, compounds, and mixtures. You may wonder why these basic definitions. In my experience of imparting chemistry education to students over many years, I found that sometimes the very basic ideas and concepts are missing. And when you try to develop the entire concept of chemistry without exactly knowing the basic ideas, sometimes that causes a problem. Therefore, this lecture. First question that is to be answered is what is an element? Very briefly, it is a basic entity that finds a place in the periodic table. I hope that we are all familiar with periodic tables. Number two, an element consists of only one type of constituent. There are no other constituents, just one single constituent. Third, an element cannot be broken or separated into any smaller entity. It's a basic entity. And as a result of all these three statements, the final statement is that all matter consists of one or more elements. This is what a periodic table looks like. I'm sure that you must have seen these things in your chemistry books. Each and every entry you see here is an element. This is an element potassium. This is an element nickel, lead, bismuth, so on and so forth. What you see here are also elements. They are called lanthanides and actinides. We'll deal with this subject separately later in another lecture. Now, there are basically two kinds of classifications that come with elements. First are metals. Second are non-metals. Metals, you are all familiar, like gold and silver and iron. They are all shiny and they conduct electricity. Non-metals mostly are, or rather usually gases at room temperature, and these are non-metals which don't conduct electricity in the manner metals do. In between these two, metals and non-metals, are a class of compounds which are called metalloids. Metalloids exhibit properties which are in between that of metals and non-metals. If you look at the periodic table, for example, the figure that you see here in this color, this is where the non-metals begin from. All the rest are metals. And that figure you see in yellow, boron, silicon, germanium, arsenic, antimony, these all are metalloids. They exhibit property somewhere between metals and non-metals. So you can see in the periodic table also the positioning is very, very specific. And you have a periodicity right here between, if this is the cut between the non-metals and metals, this is the border line. So physically it's important to understand where are my metals which are here, where are my non-metals which are here, and metalloids lie somewhere here. The second thing which is interesting and which is to be understood is what are compounds. Very, very briefly, compounds are made by joining of more than one element held together. And how are those elements held together? By a chemical bond. Let's leave the chemical bond part to a later lecture. Another thing which is very important to understand in a compound is that this combination of elements occurs in a fixed proportion by weight. It's not as if whatever you want you can add one element to other. That doesn't happen. This is fixed. You either add that proportion or you don't get that compound. The third most important to understand is once a compound is formed by two constituent elements, perhaps even more constituent elements, the property of the compound is much different from the constituent element also. you can technically break the compound back into its constituent elements, but you need a chemical method for it. So, very simply, water is a compound of hydrogen and oxygen. The common salt sodium chloride is a compound of sodium and chloride put together. Glucose is something which is good for your body. So it is a compound of carbon, hydrogen and oxygen. Carbon dioxide that you breathe out is also a compound of carbon and oxygen. Compounds are basically classified into two. First classification is inorganic compounds. These are inorganic compounds which are generally obtained from non-living things in nature, like rocks, minerals, things like that. Organic compounds are those compounds which are obtained or are present in plant and animal kingdoms. One another thing, organic compounds are mostly made up of carbon, hydrogen, nitrogen, and oxygen in most cases. The third important thing to understand is what is a mixture and what is the difference between a compound and a mixture. Compound is also formed by coming together of one or more elements. Mixture is also made by combination of two or more elements or compounds. Difference is, whereas compounds were formed by a chemical bond, in a mixture there is no chemical bond. This mixture is only mixed physically, and therefore you can mix anything to anything in any proportion that you want. That's the basic difference between the mixture and compound. Now, mixtures are also of two types. One are homogeneous, the other are heterogeneous. As the word signifies, uniform composition in the mixture is homogeneous and non-uniform distribution in the constituents is called heterogeneous mixture. The example of homogeneous mixture is a mixture of sugar and water. Once the mixture of sugar and water is made, you cannot find out which part is sugar and which is water. It becomes one. But if you, on the other hand, mix sand and water, you can clearly see where is the sand and where is the water. That's the difference between homogeneous and heterogeneous. Therefore, let's just sum up this very basic by giving a table in one shot. So you can take this down somewhere in notes, because then in examinations, they will never ask you what is the compound or what is the mixture. Mostly the question is differentiate between compounds and mixtures. So here we go again, for the sake of summing up. Compounds are formed by chemical reaction, mixtures are formed by physical mixing. In compounds, elements are fixed in ratios which cannot change. In mixtures, elements can be in any ratio which can be changed easily. Compounds are essentially homogeneous, whereas mixtures can be homogeneous as well as heterogeneous. In compounds, constituents cannot be separated physically. You can separate it chemically. But in mixture, it can be separated by physical means. If you have mixture of sand and water, just filter it out. Water is separated from the sand. Then, last but definitely not the least is that the compound form has a different characteristic from the component elements. Whereas, if it's a mixture, it shows the characteristics of constituent elements. You can see water, you can see sand. So, this is where this very short discourse comes to an end, wherein I have tried to give a very basic concept on the certain terminology that is used in repeatedly in the discussion of chemistry, and it's very important to understand what is exactly meant by an element, compound, and a mixture. The next lecture we go on to laws of chemical composition. Thank you.